We're starting Unit 2, Exponential and Logarithmic Functions, and this is Lesson 1, which is in your notes, pages 1 and 2. Determine how many times we have to multiply 2 to itself to get 8. We say, well, we'd multiply it 3 times. 2 times 2 times 2 equals 8. We use exponents, which means that we would write 2 to the third power equals 8. So that 3 indicates how many times we multiplied 2 times itself. What if I asked you, how many times do you multiply 2 times itself to get 16,384? Putting that in a calculator would be virtually impossible. It would take you forever to multiply 2 times itself a number of times and figure out how many times you multiplied it. So we use a method that's actually easier than this method, and it's called logarithms. We also call this logs. If we have a number b to the x power, some exponent x, equals another number a, we can rewrite this in what we call log form. So let's just take an example here. If we had 2 to the x power equals 8, which is exactly what we were asking up here. How many times do you multiply 2 times itself to get 8? We can write this in log form. And the way we would write this is we would write log and then base 2. Your base goes here, so this is your base here. And then your 8 would go here, and then your x after the equals. So this says the same thing, it just says it in a different way. This still says 2 to the what power equals 8. So you go in this order. If it's written in log form, you say 2 to the what power equals 8. Over here we have, I like to write this in the other way. I like to write log base b a equals x. It's just a habit for me because then I can say b to the what power equals a. So the way you would write this in exponential form or in just an equation would be b to the x power equals a, where x is your unknown. You're trying to find that. Now, so going from this to this, we can go the other way around and we can say, well, log base 2 8 equals 3, and then rewrite that as 2 to the third power equals 8. So it says the same thing. Depends on what your unknown is and whether you can figure out what your unknown is. It is important to note also that these two are what we call inverses of each other. We've done some inverses. We're going to do a lot of inverses today, get some practice on that. So it's important to note that these two are inverses. If we're talking about functions, these are inverse functions. So if I asked you to find the inverse function of an exponential function, it would end up being a log function and vice versa. So let's talk about what the graphs would look like. If we had something like b to the x power or e to the x power, and we'll talk about the number e in a few minutes, our graph would look something like this, where it starts down here and it starts to go up at what we call an exponential rate. So it looks like that. Let's stay on exponentials for just a minute. Let's say this b is a 2. That means my graph would be 2 to the x power. Okay, so 2 to the first power might be my first number. That would be 2. So 2 to the first power might be right here. 2 to the second power, 2 squared, is 4. So that's going to be a little higher. And then as I get to higher exponents, that graph really starts to shoot up. So 2 to the third power, so the 3 would be an 8. And then 2 to the fourth power would be a 16. So it jumps 1, 2, 2, 4, 3, 8, 4, 16. So by the time we get over here to 4, we're already up here at 16 on this graph. So this is one of the examples of what an exponential function graph will look like when we get to that. Let's talk about a log graph, logarithm. A logarithm graph might look like this. Log, I'm trying to get a different color here. Log x. You might also see log and then your base, 10. So this, if it's the inverse of the exponential function, then logically it's going to look something like this. So you can see where they're not very good drawings, but they would reflect over the y equals x line, which is what inverses do. All right, let's move on. Let's look at some examples. So the directions here are rewrite each exponential equation into a log equation. So let's look at that. We have 10 to the third power equals 1,000. 10 to the third power equals 1,000. We're going to rewrite this. Remember, this is the base. The base is what always goes kind of, it's a subscript to the log. So we would write log base 10 and then 1,000, and the exponent goes over here equals 3. We could also write this just log 1,000 and get used to putting parentheses around that equals 3. Because if we don't have a base here, we assume it's base 10. So base 10 is what we call the common base, or it's the assumed base if you don't have it stated. Let's look at number 2. 5 to the third power equals 125. So we would write log base 5, 125 equals 3. 4 to the negative 1 equals 0.25. Your base always goes there, subscript. This number here is in parentheses. And then your exponent is after the equals. Note that when there's a decimal, let's make a note here. When there's a decimal that is between 0 and 1, that's going to give you a negative exponent. In other words, if x is less than 1 and greater than 0, so if it's a decimal number. All right, let's look at one more. 3 to the negative 3 equals 1 over 27, and you remember your properties of exponents. If you have a negative exponent, then you put a 1 in the numerator, and the 3 cubed is going to be in the denominator, and 3 cubed is 27. So let's see, that's going to be log base 3, 1/27 equals negative 3. Again, this is a fraction that is greater than 0, less than 1, and it results in a negative exponent. All right, let's move on. Let's go the other way around. Write each log equation into an exponential equation. So you can kind of just go in a circle here. 2 to the 5th power equals 32. That's the order that it goes in. 2 to the 5th power equals 32. Okay, moving on to the next one. Lost my pen. 8 to the 1/3 power equals 2. And you can have a fraction power. We could also write this cube root of 8 equals 2. And then the last one, 5 squared equals 25. Oh, I'm sorry, I missed number 3. 5 squared equals 25. And 6, do you remember, anything to the 0 power equals 1. Okay, so that's all I'm going to do with this, rewriting logs and exponential equations, converting one to the other. If you feel like you need extra practice on this, you're going to want to go to IXL, go to the Algebra 2 section, and go to section R1. That's a good one to practice. Also, R3 would be a good one to practice once this lesson's over. It's not something I have time to spend any more time on. We need to move on. So if you feel like you need more practice on this, then go to that section and practice that on your own. For our next skill, it is essential that you know how to rewrite from exponential to log form and vice versa. So we're going to move on. We're going to start finding inverses of our exponential and log functions. And we're going to be stating the domain and range of both functions. We're going to get a lot of practice on this, both with this video lesson and in class. So as we go through these examples, I want you to notice a couple things. First of all, I have graphed the original function. I've also graphed the inverse function for each of these problems. I want you to start looking at these functions and noticing some things. First of all, this red function is this original function here. The green one's going to be what we end up with down here at the bottom when we find the inverse of it. Notice that there is an asymptote on this function here. We need to be sure that we notice that, because when we state the domain and range, we're going to be listing that asymptote as one of the starting points. So on the green graph, if you notice, there's actually a vertical asymptote on this one, and it's right here. So let's look at the red graph first. We need to go ahead and, let's go ahead and state the domain and range for the red graph first. So the domain, obviously, it comes from here, and it does keep going to the right. It looks like it almost goes straight up, but it does keep going to the right. So the domain for this graph is negative infinity to positive infinity. And the range is going to be, it starts at -8. It's really hard to see here, but it starts, this is the -8 line right here. So it starts at -8, and it does go to positive infinity. So if you remember inverses, you remember that the domain and range switch. So when we get to our log function and we look at this green graph, we should see that the domain and range are going to switch places for the green inverse graph. All right, let's get started. So if you remember our steps for finding the inverse, you remember that we changed this to a y, and then we switched the x and the y. So we're going to rewrite x equals 5y minus 8. So what I want to do is I want to solve for y. So the first thing I will do is add 8 to both sides. So x plus 8 equals 5y. Okay, so what I'm going to do, it's just me, and you don't have to do this, but I always like to rewrite this with the variable that I'm solving for on the left, and it's going to end up being on the right again, but that's okay. 5y equals x plus 8. Well, obviously, if the unknown is the exponent, I really can't solve for that without using logarithms. So the reason I use logarithms is because the unknown is in the exponent, and I need to bring it down from the exponent. So what I'm going to do is I'm going to rewrite this as a log. I'm going to change colors to the other graph. When I rewrite this as a log, I get log 5, and then get used to putting these in parentheses, x plus 8, and then my exponent is over here. So that's actually all I need to do to this one. This is my inverse function. So once I rewrite it, now sometimes there's going to be other stuff with this, and we'll have to do more after we rewrite it as a log. But I would just rewrite this as the inverse of f of x equals log base 5 x plus 8 equals, oh, I'm sorry, we don't need the other equals. So I'm just rewriting the y as the inverse of f of x. So now let's look at the green graph. And let's notice that, okay, for the domain this time, it starts over here at the -8 line. This is the -7 is the x-intercept. So the -8 line is where the domain starts. So domain starts at -8, and it does go to positive infinity on the x values, and then range starts at negative infinity and goes to positive infinity. So it did switch. The domain and range, they switched in the original and the inverse. As you look at these, I want you to start to notice some things, like the asymptote is at -8 here. Can you find a -8 in the original function? That might give us a hint to what the asymptote is going to be without looking at the graph. Same thing here, the vertical asymptote is -8 on this one, so can you figure out where you would get that -8 from the original equation? All right, let's move on. Number 2, we have an exponential function, we have a, gosh, that's hard to see. Looks like it's at 3. The horizontal asymptote's at -3, sorry. -3, and right here it's also at -3 because that's -4 right there. Also, we have some points. The x-intercept here is 2, 0. And then on the orange one, the y-intercept is 0, 2. And see how the x and y values switched? On this one, the y-intercept is 0, -2.7. And on this one, the x-intercept is the same numbers the other way around. Okay, so let's look at, I'm going to try to do the same colors as these graphs. Let me take you over to Desmos and just make sure you understand how to put this into Desmos, because you need to start using parentheses to get things where you want them. So because this whole thing is a fraction, the way we would do this is we would start out, if you want to put in g of x, you can. You really don't have to, but you can. G of x equals, and then we're going to use parentheses, and then we're going to use parentheses again because we need to make sure that we get the fraction in there. Actually, no, I don't have to use parentheses again on this one. I just need to make sure that the 3 to the x power minus 9 ends up divided by the 3. That whole thing ends up divided by the 3. So I'll enter 3 to the x power, and then you hit tab to bring that back down, minus 9, and then put that part in parentheses, and then hit your /. I must have hit something weird. /, there we go, divided by 3. So I needed to use parentheses in this top part to make sure that this whole thing was divided by 3. So just wanted to show you that real quickly. Okay, so I need to rewrite this. I need to change this to y, and then I'm going to rewrite it with changing the x and the y's. Okay, and I really could take this out of parentheses at this point, but that's fine. So the first thing I'm going to do here is I need to isolate the number and the variable. So I need to isolate the 3y. I need to get it by itself before I rewrite it in log form. Can't do that until I get the 3y by itself. So let's multiply times 3. That gets rid of the 3 denominator. And then let's add 9. So at this point, again, I like to switch this around. So it's easier for me to write it in log form. Let me switch to, find it, that's kind of orange. Okay, so now I'm going to rewrite this in log form. It's base 3, so log base 3, and then 3x plus 9 goes here, equals y. I don't know why that ended up being a dotted line. Let me see if still a dotted line. Ah, there it is. I don't know how I hit that. Okay, so equals y. All right, so I have my inverse right here. I'm just going to rewrite this as the inverse of g of x equals . Okay, so let's look at our blue graph. Let's look at domain and range. Domain here, again, -infinity to +infinity. A bit faster through these from here on. So I went ahead and wrote this, switching the x's and the y's. First thing I need to do is going to be to add 5. Trying to get this 4 and to the 3y minus 4 by itself. To get rid of this 1/2, I'm going to multiply times 2. And when I multiply times 2 over here, I have to distribute 2x plus 10. So I went ahead and wrote mine with the y on the left. I'm going to rewrite this in log form. I need to change to red. This is going to be maybe log base 4, 2x plus 10 goes in parentheses, and this is 3y minus 4. So in this case, I don't just have the y on the right side. I still am solving for y. So I'm going to add 4 to all of this. And you might already realize that I'm not only going to add 4, I'm going to divide by 3 as well. I'll go ahead and rewrite it one time like this, and then we might start skipping a couple steps. So next I need to divide by 3. And then lastly, I will rewrite this as the inverse of h and this is the inverse function. Let's look at domain and range. For the black graph, domain is all real numbers. Range starts at, what is that? -5. It's hard to see on this small graph. Starts at -5, goes to positive infinity, and then of course the red one is the opposite of that. You don't have to put that plus in there, but sometimes it helps just so you can tell that you are talking about positive infinity. Okay, so again, I want you to start looking at the graphs and thinking about where that asymptote is in the original equation, where you can find that without looking at the graph. All right, moving on, we're going to move a little more quickly. We have a blue graph that is the exponential. So I've rewritten everything and changed the x and the y. I'm going to multiply times 5. I need to get the 10 to the 3y minus 4 isolated and then rewrite as a logarithm. And I'm not going to switch them around this time. Log base 10, 5x equals 3y minus 4. Now I want you to look at this and realize that I'm going to add 4 and then I'm going to divide by 3. I'm going to combine those two steps in the next one instead of doing those one line at a time. There's my plus 4 and my divide by 3. So all I need to do now is just rewrite this as the inverse of b of x. Okay, trying to save some time on our video. Let's look at the blue domain. You may have noticed by now that all the domains on these are the same. And then the green one, switch the domain and range. All right. The next set of problems that we have, we are starting with log functions, and we are going to convert those to their inverses, and the inverses will be exponential functions. The steps in this, isolate this part right here, which is already done. Once that's isolated, we can rewrite it exponentially, because we can't really solve this thing with the log in the equation. We need to, or we can't solve for y. Let me go ahead and switch the x and the y. So I switched the x and the y, and I like to start with the log part of it on the left side. That's just my personal preference. You don't have to do that. I want you to keep in mind that this is log base 10. If it's not written there, it's implied that it's log base 10. So this is going to be rewritten as 10 to the x power equals 2y. And I'm going to switch to the other color when I do that. 10 to the x power equals 2y. Now we talked about the fact that when there's an unknown in the exponent, you can't solve for that exponent. But I'm solving for y this time. So I can solve for y and keep that x right there. I'm just going to divide by 2. So y is going to equal 10 to the x power over 2. So that's the inverse. I just need to rewrite this as the inverse of v of x. Okay, so that's my inverse function. Let's look at the original function and let's write domain and range. Remember, these are opposite of what our other ones were. So domain starts at the left, and that starts at 0. It has a vertical asymptote at 0. And it goes forever towards positive infinity. Range on this one is going to be negative infinity to positive infinity. Okay, the black graph, the domain, negative infinity to positive infinity. And the range is the same thing as the domain was up here. It starts at 0 and it goes to positive infinity on the y values. Number 2, I went ahead and switched, now I've switched the x and the y. I had x's in both places. So we need to solve for y, which means we're going to rewrite this in a minute. The first thing we have to do, though, is get the log part of it isolated. So we need to get rid of this -7. So we're going to just divide by -7, which leaves us with log base 6, -3y, equals x divided by -7. So I'm switching over to the exponential form now. Remember, the 6 is the base. Tried to get blue there. 6 is the base. The x over -7 is the exponent. And the -3y goes over here. Okay, so now to solve for y, all I need to do is divide by -3. I'm going to make this just a negative fraction because I'm going to be putting -3 under here. So y is going to equal negative, and then my numerator is going to be 6 to the x over -7 divided by 3. So that's the inverse. We just need to rewrite it with the m. Okay, let's look at domain and range. So I want you to notice, I want you to notice on the red graph, this one's different than the ones we've been looking at. The domain on this one does start at negative infinity this time. Instead of having a vertical asymptote over here, this time the vertical asymptote is on the right. And I also want you to try to notice a pattern in the fact that the vertical asymptote is on the right on this one instead of on the left. So see if there's something in this equation that's different from the ones where the vertical asymptote was on the left and it started at the asymptote. So in this case, the domain starts at negative infinity and ends at the asymptote, which is 0. And the range is still negative infinity to positive infinity. All right, looking at the blue one, again, you see that this graph is down below the x-axis this time. So again, if you can notice maybe something about this equation that's different than the other ones that would make it have the graph down below the x-axis, that will help later on when we start graphing these and looking at the graphs. So let's see, let's make sure that the domain is still, yes, it's still negative infinity to positive infinity on that one. The range is starting down here at negative infinity and it stops at 0. It's a little bit different than before. Wanted to bring you back over to Desmos and show you how to enter log functions. I haven't done that yet. So let's look at number 2 on this section. So if you need to enter a log function, you click on your keyboard, you click on functions and go to miscellaneous tab. You have log here, you have log base something else. If you're doing a log base 10, then you can just hit the log button. If you're doing a log base something else, which number 2 is log base 6, so I'll hit that. And then I'll put my 6 subscript there. And then what goes in parentheses, I have a 7. I think I have a 7 here. -7. So I'm going to put that there. And then the parentheses was -3x. So that was how I did that log function. I think that was it. -3, yep, that's it. Okay, and then I'm going to zoom out. So that's what that function looked like. I also will show you, let me see, yeah, what we got for the inverse of that one. So that one was negative So I'm going to hit negative, and then I'm going to start with parentheses. It's going to be 6 to the negative x over 7. So x divided by 7. And then I'll hit tab. I'm going to come back down here. There we go. Okay, parentheses. And then my slash button, my forward slash button, to put the 3 underneath it. So just shift 6 for exponents and parentheses when you want the whole, something more than just a number to be in the numerator. And you can see that these were inverses of each other, and they reflect across the y equals x axis, or y equals x function. So we have 2 more, and the last 2 we're not going to do the graphs. The number 3, you see how it has the x squared in it. It ends up with 2 solutions, so it's basically like 2 graphs side by side. They're mirror images of each other. So we're not going to look at that one because the inverse ends up being 2 graphs in one, basically. So we are going to find the inverse of this, but we're not going to graph them, and we're not going to do domain and range on these. So let's look at what we need to do to this one. I'm going to switch the x and y and come back. All right, so I've switched the x and the y, and now I need to rewrite it in exponential form. I'll change colors for that. It's going to be 5. Well, I thought I was changing colors. 5 to the x power equals 3y squared minus 6. I'm still solving for y, so I'm going to add 6 to both sides. 5 to the x plus 6 equals 3y squared. I can divide by 3 on both sides. But I still have a y squared. So what do I need to do to get rid of the squared? I need to square both sides. So y is going to equal, remember when you do a square root, you got to do plus or minus. So got to put that there. It's going to equal 5 to the x, square root of that, plus 6 over 3. So the positive square root of this and the negative square root of this is the inverse of this function right here. All right, let's look at number 4. So I've switched the x and the y. And we need to get the log base 2 and the 2 to the y minus 7 by itself. So I'm going to divide by 6 on both sides. The next thing I need to do is write this in exponential form. So 2 to the x over 6 okay, yep, 2 to, this is the exponent, equals this. Okay, so now I need to add 7 to both sides. Well, I still have the y as an exponent. So remember, when you have the unknown as an exponent, the only way to solve for that number is to create a log equation instead of an exponential equation. So now I need to go back to a log equation and write log base 2 to the x over 6 plus 7 equals y, and this is of course the inverse. So this inverse ended up being a log function as well, and that can't happen. We're not going to have a graph of that. We can write this as the inverse of p, so we'll rewrite that. But it is a log function. Okay, and that's it for this video. I will see you tomorrow.